Good afternoon, everybody. This is Mr. Lowe. Hey, this is the video for your assignment number 7. This is the second part of 10.7, so this is part 2. Okay. Basically, we're going to go over two basic things. This right here, finding the area of the triangle is the trickiest, and you'll find that finding the area of the shaded segment will be kind of easy once you see it today. So the first thing is not getting confused a sector with a triangle. What I have drawn right now in this circle X is a sector, AXB. That's a sector. We learned that on the last video, on the last assignment. So finding the area of the sector isn't too bad, okay? But finding the area of the triangle is a little bit weird. So here it is, triangle AXB, AXB. Now, there's no triangle yet, but if I draw a chord between A and B, then we have our triangle. So there it is, AXB. There's the triangle. Now look, now we're still looking at this sector here, okay? There's the arc AB, okay? So that's a sector, but inside the sector is the triangle. And that's what we're going to find the area of first. Well, we need some information here. So let's say that the distance from A to X and X to B, because they're both radius, right? They're both a radius or radii. Let's say that distance is, again, I've been going with 10, so let's just use 10. Okay, so 10 and 10. And the other element that we're going to need is, of course, the central angle. So we'll go ahead and call the central angle right here 60 degrees, just for our example. Okay, which means the arc measure, of course, is also 60 degrees. So to find the area of this triangle, it's just kind of like a normal triangle, where it's 1/2 times the base times the height. That's what the original formula for a triangle would be. So for any triangle, it was 1/2 the base times the height. Well, the base and the height in this case are the radii, which is the AX and XB. So what we're going to do is go 1/2 the base times the height, so to speak, because it's really not a height. But this is where the other part comes in, and it's a little tricky here. It's the last element. And then the third number here is the sine of whatever degree your central angle is. So the sine of 60 degrees. And that's the formula that you would use, okay, to solve for the area of this triangle. 1/2 10 times 10 times the sine of 60 degrees. So that's going to be, of course, that's 100. Half of 100 would be 50. 50 times the sine of 60 degrees. You would just throw that into your calculator and you should get your answer. I think it's 0.8660. So 50 times 0.8660, and that will give you an approximate answer. I had my calculator. Let's see here. Sorry. So, doing the math on that, right, we got 50 times 0.8660. So we're looking at approximately 43.3. Okay, so that's how you find the area. Which is, so the tricky part is the sine of whatever the central angle is. It's the sine of 60. That's the tricky part. So once you do that, you'll use your calculator here, come up with a decimal times by 50, and then you get your answer. Now, to find the area of the shaded segment. Now, the shaded segment is the part that is between the chord and the arc. So right there, we're going to shade it in, hence the shaded segment. So we're going to find this shaded region only. So what you need to do is basically, it's like a cookie cutter. Okay, you've got dough and you make cookies, and all the cookies are made out, in shapes of triangles. Then think of it as a cookie cutter. You put your cookie cutter down, and this is the amount of dough that would not be used to make your cookie, shaped like a triangle. So basically, to find the area of the shaded segment, all you have to do is basically take the area of the sector minus the area of the triangle, which we just found. Okay, so that's how you find the area of the shaded segment. So I'll put SS for shaded segment here, okay, in our formula. So let's go ahead and find the area of the sector very quickly. So just to kind of fly right through this part, isn't 60 out of 360 1/6? So this would be 1/6 times the area of the circle, which is pi times radius squared. So that would be 100 pi. Because the radius is 10, 10 times 10 is 100, 100 times pi, you get the idea. Okay, so that's going to be, and again, I'm just going to reduce this real quick. This would be 50 over 3 pi in terms of pi. So hopefully that's okay. I didn't go too fast. Now the area of the triangle, which we already have, is right here. Is just basically it's what, 43.3, right? And so now we'll have to change this to a decimal. No big deal. So we'll use our calculator again. We'll use 3.14 for pi. So we'll go 50 times 3.14, and then take that answer and divide it by 3. So we're looking at 52.3 repeating, which is 1/3. But we'll just, for our example, we'll just use 0.3. And so once you subtract, that'll give you the area of the shaded segment, which is right here, only that part that's shaded in. So when you do this, of course, that comes out to be 9, approximately, of course. So the area of the shaded segment here is 9, right there, all of this, only, okay? So that's it. So that should get you through the second part of the homework assignment. Hopefully, if you have any questions, you can email me. I've been trying to get back to emails as quick as I can, and I do apologize for the lateness of this video. Hopefully, this helps a lot, and I hope you guys are doing okay. Have a good day.